This is Eric Miskell with EMSNOW for another one of my up-close interviews. And my victim today is Joel with Co Young. Joel, welcome. Good to see you again. Why don't we giving a brief introduction to yourself and Co Young for those who may have been living in a cave and not know.
Sure, absolutely. And thank you again for having me, Eric. Always good to talk with you. My name is Joel Scutchfield. I am the Director of Sales for the Americas for Co Young. Co Young is the global leader in inspection technology, AOI, SPI, conformal coating inspection, pin inspection, and on and on and on and on. So we touch a lot of areas, certainly. And, we'd be very happy, obviously, to talk with your viewers in more detail, if they have interest, about a lot more of all of that.
Yeah.
But yeah,
good.
That's, I guess, in a nutshell, short and sweet.
I appreciate that. Well, listen, what I wanted to talk to you about is 3D AOI obviously is what you all do, but there's a lot of discussion that I see in the industry about 3D AOI. And it does not all seem to be the same to me. So can you kind of explain what real 3D actually is?
Yeah, absolutely. And that really is core to what Co Young is all about, is true 3D. So kind of back to who we are and what differentiates us and what the founding principles that the company was built on consist of. It really is that true 3D phenomena. And Eric, I kind of equate it to the orange juice phenomena. Okay, so you hear a lot, as you said, in the industry about 3D, right? So in some cases, I think people think if you can project a 3D image, then you are a 3D system. But that's not really the case completely, right? There's a lot more to it than that. And when I talk about the orange juice analogy, and I have to give credit to Harold Eppinger. Harold runs our European operation, who kind of came up with this analogy that really makes sense. You go to the store and you look at two bottles of orange juice, and they can be very different in terms of what's inside, right? Mm-hmm. And to get that full, true 100% orange juice content, you're probably going to pay a little bit more. Maybe it's organic. It's different, right? Versus the store brand that has fillers and additives and maybe a little bit of real orange juice, but not so much. So when we take a look at the 3D inspection, both SPI and AOI world, it's really very similar. And when you go back to the beginning, we were founded on those 3D principles. First with the SPI tool in the early 2000s, when Dr. Ko introduced the world's first dual projection moire interferometry system for SPI. We fast forward that, and that was certainly something that was very well received. A lot of the early adopters, in fact, kind of carried us to a #1 global market share position for that particular sector after only about 4 years of playing in that space. And they were actually, some of them also the drivers to a degree, development of the AOI tool, which uses, again, that same 3D technology, right? So we come from that. And when that AOI system was designed, it was designed with that same technology in mind. And to contrast that to others that are playing in this space, the only thing that existed prior to that was 2D, right? So they're all coming from that 2D world. And of course, they stood up and took notice quickly when Co Young released the first 3D, true 3D AOI Zenith system in the 2010-2011 timeframe. And since then, we've seen an abundance of people popping up with that 3D moniker. But again, it's basically a situation where, to a large degree, they're starting with their 2D system and basically bolting on some type of a 3D piece, if you will, to give either that image or some type of measurement capability. Okay. But in most cases, still using that 2D approach, if you will, for a lot of the heavy lifting in the sequence of events that occurs with an inspection system as it's doing what it does. So We kind of refer to that more as 2.5D. And so that's kind of the distinction.
Well, so that begs the question though, because, and I like that orange juice analogy. The benefit of orange juice too is you have a label on it, right? That's going to give you
Correct. Yeah.
So what are those ingredients, or what are the conditions that need to be met in order to be considered true 3D then?
Yeah, in our world, there's really three things that you have to be able to check the box on to be considered true 3D. It's getting the right kind of data first and foremost, right? And that has to be parametric, absolute, profilometric, quantitative, right? It's not analyzing, from 0 to 255 shades of black, white, and gray, right? We want parametric, absolute data. So that's number one. Number two is you have to acquire that the right way, right? What's under the hood really matters. And you need to look under the hood. You need to understand what type of mechanics and subsystems are being used to acquire that information. In our world, it's a very fine grading, highly accurate, highly precise, and use of PZT, very accurate PZT motors to move that grading, move that image through the grading 4 times to collect our 4 full 3D, true 3D images for every field of view that we inspect. And then lastly, you need enough data, right? Or the right amount, I should say. So, to be statistically relevant and to be able to use that information and call it really a robust data set for making decisions. And that's kind of where we come back to the fact that we're acquiring 32 full true 3D images for every field of view that we're inspecting with our AOI tools, in addition to another 39 2D images. So we're not completely averse to using 2D technology, but we kind of flip the script. If you take a look at the 80-20 concept, maybe for a minute, we are what I would consider to be 80% 3D, 20% 2D, where the others are opposite, right? Okay. And that's going to evolve, right? I mean, 2D certainly does have its place, and there are things you can do with that for sure. But again, 3D at the core, being true 3D is really what allows us to do everything going forward that really matters, right?
Good. Yeah. So then, how do the results attained through a true 3D process differ from one that is not true 3D?
So I kind of touched on that previously when I mentioned that there are various elements of the process that can be done in 3D or in 2D. And, in our world, we being full true 3D, we obviously skew to those concepts where these 2.5D providers, because they come from that 2D world, are still using binarization and blobbing for things like body and lead tip find. And unfortunately, that's very subjective. And it's probably one of the highest contributors to false calls that there is in the AOI inspection world. So we take all of that off the table right up front, right? And then not to mention the fact that the data set that we're actually acquiring, again, is absolute. It's parametric. It can be used to now fuel a proprietary AI engine, which we are also very involved with, that's designed around that data set, that type of data, to give us tools that enhance auto programming and, again, control of the screen printer if the customer so allows, mount feedback to be able to make adjustments for things like feeder, spindle, nozzle anomalies and speed, pressure, and release at the print process and feeding back from the SPI. So, machine learning, the AI application, all comes from that true 3D data set. And, without that, it's really very difficult, if not impossible, to really achieve that whole smart factory initiative that people are chasing.
Yeah. And you bring up a good point, because obviously the AOI is one component within the manufacturing line. Mm-hmm. How do the results achieved by the system impact subsequent manufacturing processes then?
Well, the concept that's being really taken forward. I won't say even talked about at this point. We are well into this whole connected factory initiative now, right? With the CFX initiative and all of the the kind of the sub underlying partnerships from the various players that are out there to create connectivity and to try to achieve that self-healing concept that I talked about, where if you see something, you can feedback and make corrections on the fly without any human intervention. I think that's really the key, right? So we can do things within our own Co-Young world to feed information from the AOI at both post and pre to our SPI, provide information to our customers real time for very fast correlation of that data and information and what it's meaning. But then the next step is obviously to be able to communicate with the pick and place manufacturers, the screen printer manufacturers. And we're doing that as well, both through our own initiatives and more recently now through the CFX initiatives, which we're very involved with as well.
So you're touching on some of this already, but I'm going to ask it anyway. So when you're thinking about more future-oriented production, what variables need to be taken into consideration then?
Well, certainly from a manufacturer's perspective, the equipment that they are going to invest in will need to have this capability of connectivity first and foremost, and would also be very prudent as a manufacturer to understand that you need this very granular data set now going forward, this robust data set going forward to have that measurement resolution to make the kinds of changes and adjustments that are going to be needed in any piece of equipment that you buy. So I think, that focus on making sure that you have that granularity is going to be important, as well as, really almost redefining the design for manufacturability definition. And, years past, and I guess this probably still happens in applications today, depending on the product, your reliability testing was either a, humidity cycling or some kind of a shake test for an extended period of time. And again, that's still very valid, but there's so much more data available now and will be going forward to, potentially, eliminate some of that if the conditions are right. So, there's a lot of things to consider, but I think it really just comes down to, really two things: connectivity capability and the ability for that tool to generate the right kind of parametric, absolute, robust data that you can really believe in. And when it comes to, trusting that to either an AI engine or making adjustments up and down the line.
Yeah. So, and that's interesting about the data, I think. So to what extent then should the data collected from an assembly or a component or even a parameter of an individual joint be considered reliable?
That's a great question. And the short answer is it really varies. It kind of depends on what you're building to a degree, right? Maybe more for high reliability products or complex assemblies that are less able to be maybe reproduced easily, and then less for games and other low reliability applications. I think the key, Eric, anytime we're talking about data, is making sure it's manageable, making sure it's usable, right? We spit out a lot of data right now. Our competitors and other partners up and down the line, spit out a lot of data, right? We have to make it manageable, both in an automated fashion for our partners and other systems, the additional systems up and down the line to be able to receive it, but also from a human element perspective, from an analysis perspective. So I think the real drive here is not so much how much, but how do we make it usable quickly, right? How do we take that information, put it in a format where either another machine or a human can potentially do something with it real time, right?
Yeah. Okay, so then and that's important with the data. So is it then also important to have a clear distinction among the assembly data, the process data, and the production tolerances in order to achieve meaningful manufacturing control?
Well, the tolerances applied are certainly going to affect the results, right? I think the key is that customers want to have assurance that they're not going to ship bad product, right? They're not going to have escapes, as we like to call it, and that's not just from our tool. That's off the line, right? That's their line reliability. So that being the key, I mean, you need to understand that as those tolerances are adjusted, the results so too will be changed, right? So it all does tie together to some degree, but again, I think you have to look through it through those eyes to really understand production, process, assembly, because in an assembly situation, right, that they're in many cases very different, right? We have a lot of EMS customers that build very different products, from very simple to very complex. So, again, it's the understanding of how those tolerances and how the information that you apply is going to affect how that line reacts and the kind of results that you're going to get from the setup that you've put together. And again, I'm not just talking about our system. I'm talking completely up and down the line, right? The real concept here is that we're trying to get to the point where the line is a machine, right? It's a single system that that basically you start at one end and you push the button and it pops out the other end, and you put it in a box, right?
Yeah. But yeah, this is good. I mean, this has helped me, quite frankly, and I'm sure it's helped the audience too to understand a little better about what that true 3D AOI really is. And I love the orange juice comparison. It's a great analogy. And
yeah, it really makes sense, and it's a very real situation, and we encourage people to take a much closer look. Not all 3D was created equal, so you need to really understand that, and really also understand again the effects of what that data set that true 3D produces is going to do for you up and down the line as you go forward. So like I tell people, it's not a one-time investment in an AOI tool. You really have to understand the effects of what that system can provide back to the screen printing process, forward to other processes down the line, feeding back to the mounters, and know that when you whoever you settle up with needs to have the capability to be able to handle all of that, because whether you're using it today, whether it's important to you today or not, it will be in the future. That's just out of if nothing else, the evolution of where the industry's going and where we're headed.
Yeah. No, I appreciate that, and I think the viewers will appreciate that as well.
I hope so. Yeah.
So thank you for taking the time to share with us today. I will say to the audience that he is Joel Scutchfield. He is with Co-Young, although we haven't been talking about Co-Young's specific products here. If you want to know more about any of this that we're talking about, look him up. He's undoubtedly on LinkedIn, as we all are these days.
I am, and we have the website alive and ready. So come see us.
Come see him. Well, Joel, thank you again, sir, for the time. I wish you nothing but a happy holidays and a good, safe end to this year. And as we're all hoping for one hell of a better year next year.
We certainly are. And I, right back at you, Eric. Thank you very much for the time and the opportunity today. I hope you and your viewers will find this to be very helpful. And as you said, if more information is needed or wanted in any way, please look us up. We'd be more than happy to share that. And happy holidays to you and to all your viewers.
Thank you very much, sir.
Hope we can do it again in 2021 in person somewhere.
In
Wouldn't that
person
be nice?
somewhere,
Like-
yeah.
like we
That
used
may
to.
not be till mid-year or so, but
I think you're right. I think you're right.
we're all looking forward to that. Okay.
It'll be here before we know it.
Yeah, exactly. Again, Joel, thank you, sir. Appreciate your time today.
Thank you, Eric. Have a good day.
You too.